This video is to go over Unit 1, Practice Quiz 1. These questions are going to be incredibly similar to the actual quiz, so if you feel comfortable with this, you'll do just fine. Saying that though, please make sure you can actually do the problems yourself. Just watching this and saying, oh, that makes sense to me, is not going to be enough. Go back, try the problems alone, without answers in front of you, and make sure you can actually do it yourself. We need to practice the math in order to get better at it. You can't just look at it. So let's jump into it here. Our equation that we're looking at first is here. And always make sure you read what happens, what's coming up before that equation, because this is going to tell us what our variables mean. So milliliters is ml, and cups is C. So there's a relationship between these two units of measure. So the number of milliliters is equal to the number of cups times 240. So for example, 1 cup would be 240 milliliters, 2 cups would be 480 milliliters, and so on. First question is, how are these variables related? Directly, inversely, or neither? And you can look at our list of equations, and hopefully you'll notice that this is direct. It looks exactly like our example that says y equals kx. So this question doesn't actually ask this of us, but if we were asked what the constant of proportionality is, that is the k value, and what aligns with that in our equation is this 240. So this is direct variation, and as far as giving reasoning, you could even just say that it matches our base form or direct variation form of y equals kx. And if it asked you for a constant of proportionality, you could say k equals 240. Moving on, we're going to use this equation to, we'll be given one variable and solve for the other. This is a pretty common thing with equations. I will write our equation down here again just to have that fresh here. So milliliters is equal to 240 C. It's really important to remember in this that 240 C really means 240 times C. That's multiplication. It's going to give us one variable, so always look for what it tells us. So it's giving us a number of cups, and it's asking how many milliliters. So it's giving us a value of C, and it's asking for a value of ml. Whenever it gives you a number for one of your variables, that means you can just plug it in or substitute it in. So milliliters is equal to 240 times 2.25. Because the number of cups is 2.25, we can just substitute that in. When you do the multiplication here, you get the number of milliliters is equal to 540. Next, we'll be given a different variable. And so now we're looking at question 1, part C. We are given milliliters. So it tells us we have 100 milliliters, or if we need 100 milliliters, we want to know how many cups is that. So we're given milliliters this time, so our equation is ml equals 240C. And we're given milliliters, so let's plug that in. 100 is equal to 240C. So we plug in what we know. Everything else stays exactly the same. But now we're trying to find C. So we need to get C by itself. We need to get C equals something. Since those are multiplied together, 240 times C, we can divide by 240. That will leave us with just C on that right side. But whatever we do to one side, we have to do to the other. So C would be equal to, C is equal to 100 divided by 240, which is 0.42 approximately. Okay. So 100 milliliters is approximately 0.42 cups. Write the equation in a different yet symbolically equivalent form. what this means is, and this will be a little more clear on the actual quiz, write an equation that means the exact same thing but looks different. So our base equation is ML equals 240C. One thing we could do to both sides of this equation is just divide by C. And that would give us a new equation, because these would cancel out. That would give us a new equation, ML over C equals 240. And so that would be an example of an equation that means the same thing. I haven't changed the relationship of the variables, it just looks different. You might have also gotten ML over 240 equals C. These all mean the exact same thing. But when it asks us this, we want to move something. Moving on to number 2. Again, you want to make sure you read through this so that you have a context for our equation. One important thing out of this is that our flashlight is rated at 90 lumens. That means L is 90, always. For every question moving forward, L is 90. Outside of that, we're looking at the relationship between meters X and intensity I. If I was going through, I might highlight or circle this on a quiz just so that I make sure I know what I'm looking for. So I'm going to rewrite this equation right away. I equals 90 over X squared. Since I know L is 90, let's just write it so I don't ever forget. This is my equation that I'm going to want to use for all of my calculations. And the first question is this direct or inverse? And it looks exactly like our form, y equals k over x. Exactly like that. So this is inverse variation. Inverse variation, and again, variation. Again, you can just say, because it looks exactly like this form that we know is inverse variation. Constant of proportionality, k value, it's that number in our equation. In this case, that number is 90. K is equal to 90. And we know, because we know that k is the constant of proportionality, and in our equation, k is replaced by 90. So you'd want to write something, say something about that. Moving forward, again, we're going to be given some variable, and we're going to be asked to solve for the other. So in this problem, we are given a distance, and we are asked about the intensity. So distance is our variable x, and intensity is our variable I. So we're given x, we want I. So we take our base equation, I equals 90 over x squared, and we're going to let x equal 3 because it tells us our distance is 3. So I equals 90 over 3 squared. So all I'm doing is replacing the x with the 3. And there's not really any solving here to do. We just need to do some math, right? We already have it in the form I equals, so we're good. We just need to do this math following order of operations, which would tell us that we need to do the squaring first, because I have 3 squared, but I also have a division. So we need to do our exponents first, and then our division. So this would be equal to 90. 3 squared is 9. 90 divided by 9 is 10. So that's our final answer. The intensity would be 10. Next question. If the intensity, so now it's giving us intensity, if the intensity is 360, and you don't need to worry about all the letters here, this is just like units. So 360 lumens per meter squared. Okay, all we're going to do is we're going to input 360 for I. And then the question is, how far? How far away? So that's going to be our x. We're given I, and we're finding x. So again, take our equation, I equals 90 over x squared. But now instead of I, we have 360. 360 over, actually I'm going to make a little room because we have some calculations to do here. So I'm going to start this over, and I'm just going to write it right in our equation. 360 equals 90 over x squared. So now we need to do some solving, some rearranging to get our value of x. So we're trying to find the value of x. We've talked about this before. When our variable we're trying to find is on the bottom, the first thing we need to do is multiply by that variable. Whatever we do to one side, we have to do to the other. I have x squared on the top here, x squared on the bottom. Those are going to cancel out. We end up with 360 x squared equals 90. Now we're closer to getting our x. We've got it in the top of the equation now, which is good, but we've still got some work to do. So when we're solving for a variable, we want to go in the opposite order of operations, meaning I want to do exponents last, and then I will want to do the multiplication next to last. So this is 360 times x squared. In order to undo that, we're going to divide by 360. As a result, we get x squared equals 90 divided by 360. And 90 divided by 360 is equal to 1/4. Let's just do it this way, which is equal to 1/4. So x squared is equal to 1/4. And to undo the squaring, if I want just x instead of x squared, I need to take the square root. And if you put this into a calculator, you will get x equals 1/2. Or if you want to write it as 0.5, that's the same thing. So final answer, when intensity is 360, our distance is 0.5 meters. Finally, a number of ways we could rearrange this. So we'll go with our original equation, I equals 90 over x squared. I would probably just multiply both sides by x squared to make this look different. That way these will cancel out. My new equation would be ix squared equals 90. And again, we haven't changed the meaning of anything, but I have created another equation that means the same thing and just looks different. Final piece, we need to match up some equations with some graphs. So I would highly recommend using this tool we have down here. I will actually drag this up, maybe I can drag this up, maybe not. I think I just need the other tool. There we go. All right, so let's do that. Let's drag this up so that I can show you this while we're actually looking at the graphs. So what you want to do, this is the way I do it. Some people you may choose to start with the equations and then look at the graphs. I like to look at the graphs and then match them up with the equations. So for example, if we're going to look at this first graph here, I want to compare that to my base graphs. So anything on this side is inverse. Anything over here is direct. Anything here is even. And anything here has an odd R value. So based on each part of this diagram, so if for example, if it matched this diagram, it would be direct and even. The one we're looking at right now looks just like this. So that means it is inverse variation and R is even. So what you could do is you could just write that on here. Inverse, even, R value. I'm just going to say, let's just do it this way. Let's just say R is even. And the final thing we need to think about is the K value. So if our graph looks exactly like our model, so if our graph looks exactly like this, which it does, then we know that that K value is positive, because what the K does is it flips it over the axis. So if K were negative, it would flip over this axis and it would actually look like this. But it doesn't. It's the same shape facing up, so we know that K is positive K is positive. All right, I am going to move this out of the way so that we can look at another graph. Actually, here's what we'll do. We're not going to end up doing all of them for the sake of time, but I want to look at a couple others. So let's just do, my writing kind of goes over the top of that. I wasn't expecting that to happen. So let's do this here. I will just take this and I will move it out of the way. All right, and then we can move this up here. That works a little bit better. It will work much better when it's not overlapping on your paper. So now we're looking here, and I want to say, which graph does this look like? And I'm hoping that you realize it looks like this. However, this base graph goes this direction, and ours goes like this. So it is going to be direct. It is going to be an odd R value, but since it's flipped like that, we know that K must be negative. So this is direct. R is odd, and K is negative because it's flipped. So this is the same process you're going to want to follow with all of these. So just identify which graph it looks like. That way you can determine direct or inverse, even or odd, and then if it's flipped, that will tell you that K is negative. So I will just go through really quickly and share that with you. Here, I'm going to restart on this one. This was inverse, even, and positive. This is going to be inverse, odd, and positive. So if you hadn't done these yet, this would be a good time to pause the video and try to do them yourself, and then come back and check your answers. This would be inverse, odd, and negative, because it would be flipped. This is direct. This is even and positive. And notice these two look exactly the same. They are both direct, even, and positive. However, one is wider than the other. Since this one on the right is wider, we know that that K value must be smaller. So when we go and try to match them up with the equations, whatever has a smaller K value will be this one, and the larger K value will be the one on the left. So let's match these up real quick. So if I'm looking for inverse, even, and positive, these three are my inverse variation problems. And if I'm looking at the R values, remember R is the exponent, only one of them has an even exponent, so it has to be this one. On the actual quiz, there will be a place to write the equation y equals 3 over x to the 4th. And now we could cross that one off because they're only going to be used once. Next, we'll look for inverse, odd, and positive. So these are my two remaining inverse variations. Only one of them is positive. This one is positive and odd, so it must be that. Y equals 5 over x to the 3rd. And this one over here, direct variation, R is odd, K is negative. That matches up with this. Y equals negative 3x cubed. That means this has to be my negative 1 over x. Y equals negative 1 over x. And then these final two, remember the more narrow one has the higher x value. That's going to make it stretch and grow faster. So this one has to be y equals 4x squared. And this one has to be 1/2 x squared. If you were ever not able to follow this pattern or remember how this works, something you could always do is just plug in numbers for x and then find the value of y. That would allow you to plot some points and get the general shape. So that's always kind of a fallback. So you can always make a table to figure out what the graph might look like, to figure out graph shape. Sorry, that's a little sloppy, but you get the idea. So choose an x value, plug it into the equation, and get the y.